In this video, we're going to take a look at how ethers react with acids like HCl and HBr. Let's jump right in. If we have an ether, a carbon, oxygen, carbon, and we react that with an acid like HBr, well, we know that acids like this are sources of H+. So this would have H+ and Br- in it. Well, if it's a source of H+, where's the most negative spot on here? Of course, it's these negative juicy electrons. So they'll come and attack the H+. So now the oxygen has a +1 formal charge. Now, whenever it's protonated, that makes it a very good leaving group. We have a R group with an OH that can leave. So, for instance, my Br- could backside attack this carbon, and this is a very good leaving group. So I have 3 carbons with a bromine on it, and I have an ethyl group with an O and H and 2 lone pairs now. These electrons are now on the oxygen. So this neutral alcohol is a very stable, very good leaving group. And if there's still acid in there, more HBr, these electrons could grab the H+. The good leaving group bromide can leave. So now my oxygen has 2 hydrogens on it. My oxygen has a +1 formal charge. And now I have this water leaving group. So this very good leaving group is a neutral water. So again, I have Br- in there. I could backside attack. This stable water could leave. So I have ethyl bromide and water was my leaving group. So I made 2 bromide compounds. So in effect, I cleaved between this carbon-oxygen bond, and I added the bromine on that carbon. And I cleaved between this carbon-oxygen bond and added the bromine to that carbon. So normally we cleave both sides, and we add our, whatever the leaving group is, to that carbon. Let's take a look at when this backside attack doesn't happen. It normally happens with most carbon groups unless there's a double bond on that carbon. Let's do the same reaction, except this time we'll have a phenyl on my ether. Maybe we'll put a methyl on this side. So we have this methyl phenyl ether. And let's react it with HI. So again, we have a source of H+, and we have some I-. So which part reacts with the H+? Again, these juicy negative electrons on the oxygen. So we'll have a phenyl, oxygen, methyl. We have our hydrogen on the oxygen and a +1 formal charge on the oxygen. Again, we have a very good leaving group, an alcohol leaving group. So my Br-, oh, nope, I have I- in this case. My I- can backside attack my methyl. My alcohol leaving group leave. So we have phenyl with an OH. And now 2 lone pairs of electrons. These 2 electrons are a lone pair. And we have methyl iodide. So we have this very stable leaving group alcohol and the methyl iodide. There's more HI in there. We can protonate the alcohol, just like we did with that last reaction. Except now my phenol is protonated, +1 formal charge, good leaving group, except this can't happen. We can't attack a double bonded carbon atom with our I-. We can't backside attack. It doesn't want a carbocation. So this part is not going to work. So that means we're stuck with the phenol. So when this happens, we can cleave here and put a bromine on the methyl, but we cannot cleave this side. So whenever you have a phenol or a double bonded compound, This part makes phenyl OH, and this part is the part with the bromine or the iodine on it. So we made these two compounds when I'm done. All right, so the thing to remember is if you have an ether, we can cleave both sides and put an iodine or a bromine on those carbons, unless that carbon has a double bond. Then you end up with the alcohol. I hope that helps. So subscribe to the channel and watch more of my organic chemistry videos so I can help you be successful.